So before we move on to the next module, we'll just talk real briefly about how ACI is able to significantly reduce TCAM policy table. Let's just say this was, for instance, could be a firewall, could be a, let's say, Cat 6500 or Nexus 7K. Even if I put all of my sources, I have 5 sources, into a, let's say, network object group, okay? I still have 5 sources. And let's say I have 5 filters. Some allows, some denies, some allows, some denies, whatever. And then I have 4 destinations. Regardless of even if I put these into the sources all into a single object group and the destinations into an object group, even though command line would, from a show run perspective, would only show me from the source group allow to the destination group, from the source group line 2 deny to the destination group, from the source group line 3 allow to the destination group, from the source group line 4 deny to the destination group, and finally from the source group 5 allow to the destination. Even though I only show 5 lines in the show run, what gets enumerated in the TCAM is actually 5 times 5 times 4, or 100 TCAM entries. So this doesn't really, this presents a limitation in terms of TCAM scalability. In ACI, the source EPG is one class ID. So really there is one line in the ACL, in the TCAM, which is source class ID or EPG, and the destination class ID or EPG, and then the number of filters. So it wouldn't matter if you scaled 100 or 1,000 endpoints inside your source and 100 or 1,000 or 5,000, whatever, in your destination. It would always be one source to one destination times the number of filters. So 1 times 5 times 1, we only require 5 entries regardless of the number of sources and destinations or endpoints within any 2 EPGs. So next, let's talk about application network profiles, or ANPs, and their contracts. So ANPs are really just a logical grouping of endpoint groups and the contracts that define the communication between them. So why do we even have this collection? Well, keep in mind, ACI is the infrastructure, I'll start backwards, that's centered around the application, right? So the application-centric infrastructure. So everything is modeled around the ANP, the application. That's what's the most important thing in our data center anyhow. So it's important to design and build according to the application. Of course, there are alternative legacy design modes that we'll go over as alternative cases, and a lot of people start out there, and that's perfectly fine. But the idea is getting your network designed around your applications for tons of future usage and scalability. And one of these things is, deleting an application, you're done with it. Maybe you're going on to a brand new model, and you delete the ANP, and it clears up all the TCAM space, deletes everything that's not needed in terms of policies. Maybe I delete a tenant and everything's gone, the VRFs, the SVIs, all the ACLs, all the OSPF or EIGRP or BGP instances, everything is gone without affecting any other tenant. Okay, so I can delete an application, I can delete a tenant, I can clean up, cruft, I can have policy enforcement and compliance, but I also get that health score for the ANP. So I can tell how healthy any one of my applications are, and if there's a problem, if it's below 100, what is the degradation therefore? What is driving, what specifically is causing the degradation of health score? And remember, I can just drill down, and we'll take a lot more of a look at that in troubleshooting and in the live demos. I can drill down and see specifically what is causing that problem. Now, a contract is between EPGs. So this defines the policy of how one EPG communicates with another. So within a contract, I have to have, first of all, a subject. The subject is what is being discussed. Okay? The subject contains a filter. So the filter you could think of really as an ACL. Okay? The filter would say, destination port 80, for instance, or destination port 443, or a particular source port, maybe source port 80. And this is where we'll talk about at the filter level, we can tick a box to turn on whether the filter is stateful or stateless. So we do have stateful firewall and stateless. Now, if you're watching this and you're kind of looking at your own ACI fabric at the same time and you're saying, I don't see that tick box for stateful, you probably have older code, 1.0 code. So again, this is based on, or this is a feature, this one stateful. The contracts and the subjects and the filters are not. They've been there forever. But the stateful is a feature of ACI 1.1, the Brahmaputra code. So now we have also the action. So what action should we take? Permit, deny, flag, copy. And then there's something that we won't go into now. Actually, we won't go into in this course at all. This will be in an advanced course because this really opens up Pandora's box, a lot of functionality, but it also is a lot of explanation of what labels are. So label is something that we can tag something. It's not only metadata, but that's basically what it is metadata, and we can use that for various things. We may get into that actually with DHCP relay in this course. So at an ANP, we define which EPGs can communicate, and we have this contract idea of provider-consumer relationship. So here we see the application that's modeled. Maybe it's our Web 3.0 app. And we have our database farm providing a contract being consumed by the application, and maybe the contract has a filter with the destination port of MySQL, okay, MySQL. So that would be, the destination port would be the database farm or the MySQL port, and that would be that contract would be provided by the database and consumed by the application EPG. The app EPG would, in this example, has a two separate one-way or a two-way contract, if we want to call it that. The app EPG is providing a contract to the web, and the web is providing a contract to the app. Maybe the app is Tomcat and providing 8080 and 8443. The contract might do things like invoke other services. It might just be a simple firewall rule. And then the web is providing a contract for port 80 and port 443, most likely redirecting to a firewall and a load balancer if L4 through 7 are being controlled through ACI. If they're not, then we would simply allow that traffic over to the users, and then the users are consuming that contract. So here's a more detailed example of this contract where the subject is just a name. We can call it what we want. And then the filter would be TCP port 80 being provided by the web, consumed by the users, and the action is to permit, and maybe we've given it a label such as web access. And we can have multiple subjects per contract. That way we can have different types of services that are offered. So the actions in the policy, the current ones are essentially to permit traffic, to deny or block traffic, and this is a special kind of contract. It's actually a different contract that we create called Taboo. So actually when we look at the demo, I'll just go back. When we go in to create a contract and then we create our subject, we'll see a place to create the filter and a label, but you won't see an action. So there won't be a permit. So what you should note in ACI is that if you create what's just called a contract, plain and simple, it is an implicit permit. So contracts always permit. But there is a special kind of a contract called a taboo contract, which we'll talk more about here, and it's named something different, taboo contract, right? Like the things we won't talk about. So this is actually the action of deny or block. Now a contract can certainly redirect traffic to L4 through 7, so that's another action, or we can mark DSCP. Some future options would be to log those as well as to copy. Now, we do already have support for span and ER span in the fabric, so why would we need copy? Well, span is going to span everything from a particular port or possibly just from a particular EPG. We can narrow it down just to that, and that's going to be in the troubleshooting section. but maybe we just want to copy port 80 traffic only. Well, in that case, it would be nice to be able to go ahead and copy a packet from a contract. So that's coming. So here's an example of some shared services, such as our application and our web farm both need access to DNS and DHCP for PXE booting, for Puppet or Ansible configuration. So here we have DNS and DHCP that are providing a contract. The contract is, let's say, Active Directory. That's the name. It's got multiple subjects with filters that define the ports for DNS and DHCP. Okay? And really the providers are abstracted away by the contract. So all we need to know is consume the contract. And again, if these were in the common tenant and the common VRF, and these app and web were in a specific tenant and a specific VRF, then note that as long as we had shared flagged for our subnets in DNS DHCP bridge domains and in our app web bridge domains subnets, the route leaking would be configured as soon as we did the contract. So here's what I was mentioning about a taboo contract. This is an explicit deny. So the explicit deny basically states that we should never allow certain traffic for a particular EPG endpoint in a group. So for instance, maybe I have a traditional app and web tier. So let's say my web farm is consuming the app contract from the app EPG, which is not pictured here. And the web farm is providing the web contract over to the end user's EPG, which is not pictured here. But I also attached to this web EPG have a taboo contract. So this is actually going to be enforced before all other contracts. So what you might think of is traditional contracts are, and their filters are permit statements in an ACL. And then the taboo contract are the deny ACEs, or access control entries within the ACL. Those filters are the deny ACEs. So they're automatically positioned at the very top of the ACL. And finally, we'll touch briefly on ACI quality of service. So ACI overall QoS process flow is that traffic coming in to the ingress leaf can have classification, marking, buffering, and queuing. Then when it traverses up to the spine, routes up to the spine, we can perform buffering and queuing. And then when we go out to the egress leaf, we can perform buffering and queuing. So really at all three stages, buffering and queuing are performed. Classification and marking occur only at the ingress. Now ACI currently has 3 user configurable classes of service called level 1, 2, and 3, which is the default. Some of the options that we can do in a contract, we can deal with DSCP and 802.1q.1p, as well as at the EPG level. We can mark traffic, we can do strict priority queuing, as well as deficit weighted round robining. Wanted to say distributed, but of course that's deficit weighted round robining. The class ID, or essentially the EPG class ID, or the identity of the EPG, is carried in the .1p bits of the VXLAN outer header. And then there is no reclassification on the spine or egress leaf currently. So for instance, I have EPG app1 providing a set QoS contract, and it's being consumed by EPG2. Okay? So at this point, we want to set the priority level for all traffic between my EPG1 and EPG2 to QoS level 1. So taking a look at custom QoS under the EPG, at the EPG I can set custom QoS here. And so for the properties of this, I could have, for instance, DSCP to priority map. So here we can see that I'm basically matching on AF31 to AF33, and I am classifying that or marking that as QoS level 2, and then I'm classifying on the EPG called set priority on the EPG, I'm classifying AF41 to 43 to level 1. So assured forwarding for 1 and for 3, actually for 1, for 2, and for 3, okay, which we of course know that we have 3 drop precedent levels for every class. So the class being that first decimal value of 4 or 3, the drop probability being low for 1, 2 being medium, or 3 being a high probability for drop. If we had, for instance, let's say weighted red turned on, those 4.1, 4.2, and 4.3 would be mapped or marked to level 1. We can also classify based on .1p, but if we have DSCP visible in the ingress header, we will use DSCP takes precedence over .1p. And so then also just keep track of and note that, of course, unless we set a QoS level at an EPG, specifically, it will by default be assigned to the default level 3. So now kind of taking a complete look at our application network profile to round out this module. We saw this before in the last module where we had our EPG database with their endpoints, providing the SQL contract consumed by the app EPG with its endpoints, and it was providing the Tomcat or Java contract being consumed by the web EPG with its endpoints, and it was providing the web contract consumed by the public. Now the public outside we'll talk more about in the layer 3 routed outside. This could be identified by a single, actually it could be a layer 2 VLAN, that's how it's assigned or identified. This is an EPG, whether it's a L2 out or a layer 3 routed outside. If it's a layer 3 routed, it could be classified by the subnets. Okay? It also could just be classified by a single subnet that we state is 0000/0, which basically says everyone. And then it is LPM, longest prefix match, so if we have more specific subnets for the same L3 out, then they would dictate or form the basis for another EPG through the same L3 out. Now, in this case, all 4 EPGs, our L3 out, our web, our app, and our DB, are all a part of the same layer 3 context or VRF, private network. Each of these web, app, and database have different and separate VXLAN, VNI bridge domains. They don't have to, but in this case they do. And now we're going to add a few other things. So in our SQL contract, we'll add a SQL filter. Our Java contract will add our Java filter. And in our web contract, we'll add our web filter. Of course, we could set QoS here. We also could do something like redirect to L4 through 7. Then let's say we want to add more onto this and we want to include our EPG for services. Those endpoints could have a shared services contract, and really this would be in common. So it's just saying it's shared through the infrastructure, but really it should be maybe labeled common would be a better way to label that. I'll change that. And it has a DNS filter and an Active Directory filter. Maybe NTP as well, maybe DHCP as well. And those are being provided from the EPG service, either in the same tenant or most likely in the common tenant, and consumed by the database, also consumed by the app, also consumed by the web. And then I thought I had it in this slide, but it doesn't look like it. I also could have maybe another contract that's being provided by the database, by the app, and by the web, to another L3 out, or actually the same L3 out but different subnets, and those could be the developers, and that contract, the developer subnet is, which forms another EPG, is consuming, and that actually, like I said, represents the developers, and maybe they have SSH access into each of these devices. So actually, I just added this. So I just changed everything. This is the beauty of post-production, right? But I just changed this so now the L3 outside is actually broken down into 2 separate EPGs represented by the 0000 subnet consuming the web contract, so everyone gets this. Everyone that doesn't fall into the specific development subnet, which is 10.19.21.0/24, it's consuming a different contract, which is the dev contract, being provided by the web app and database, which has the SSH filter. So again, this would allow me to have different EPGs providing and consuming different contracts and allowing very granular types of control. So now that we've gone through all of this, I want to bring us back real quickly to the Fabric Access Policies logical model, just to bring in to now we've been talking on this module strictly about the Tenant tab, and we now have the EPG, right? And the EPG is the who is the endpoint on our network. And remember, that goes back to the domain, which is how we know about them. Do we know about them by their VLAN ID, by their VXLAN ID, and of course with our new micro EPGs, could even be VM name, things like that. And then where on the ACI physical fabric did we learn about them? That's the Attachable Entity Profile, or AEP, that software glue. And that points back and links to our interface on a particular switch node. And here's kind of another view of this from a holistic perspective. Here on the left we have our Tenant tab, and on the right we have our Fabric Access Policies tab. So from the root universe we have our single tenant. Of course we could have multiple tenants. It has at least one application network profile with one endpoint group. The endpoint group is directly linked to a L2 bridge domain, which has a subnet or an SVI that's associated to an L3 VRF. Ignore those lines for now. All the solid lines are associations, not necessarily parent-child hierarchy, though in some case it is. For instance, uni to tenant to ANP, that is a hierarchy, and really then EPG. But then some of the others, L2 bridge domain is a direct hierarchy of the tenant and at the same level as the ANP, hierarchically speaking, and the VRF is also at the same level, sub to the tenant or child to the tenant, hierarchically speaking. But these blue lines are more the associations. So the VLAN pool feeds into either the VMM or the physical domain, and the VMM pool would either be dynamic allocation for VMM or static allocation for physical. And the linkage between the Tenant tab and the Fabric Access Policies is this EPG to domain association or mapping. The domain associates into the AEP, which says where we find things. So the EPG is the who, the domain is the how, and the AEP is the where, on which interface, policy group as well as policies. So policies get created and put inside policy groups. Those get applied, the policy groups get applied to the interfaces, and more specifically, not just to the interface profile, but the interface selector. And then that goes to the leaf switch or switch profile and switch selector. So that's kind of a more complete view of everything.